How to calculate gas properties using moles. Imagine you're trying to figure out how much space a certain amount of gas will take up or how hot it needs to be to expand. Calculating gas properties using moles helps you do just that. It all starts with a simple but powerful equation called the ideal gas law. The law links pressure, volume, temperature, and the amount of gas in moles. The equation looks like this. Pressure times volume equals moles times the gas constant times temperature. The pressure is how hard the gas pushes against its container, usually measured in pascals or atmospheres. The volume is the space the gas fills, measured in liters or cubic meters. The temperature is in Kelvin, which is just Celsius plus 273. The moles tell us how many particles are present, based on Avogadro's number, which is about 6.02 times 10 to the 23rd particles per mole. The gas constant is a fixed number, 8.31 for joules per mole Kelvin. If you know 3 of these variables, you can find the 4th. For example, if you know the amount of gas in moles, the pressure, and the temperature, you can find the volume by rearranging the equation. Volume equals moles times the gas constant times temperature divided by pressure. Conversely, if you know the pressure, volume, and moles, you can find the temperature by multiplying pressure and volume and dividing by moles times the gas constant. This law is really handy because it combines 3 simpler laws: Boyle's law, Charles's law, and Avogadro's law. Boyle's law says that at constant temperature, pressure and volume are inversely related. Charles's law states that at constant pressure, volume goes up as temperature rises. And Avogadro's law tells us that at constant temperature and pressure, volume increases with the number of moles. Using this law, you can predict how gases will behave when conditions change. For example, if you add more moles of gas to a container, the volume will increase if the pressure and temperature stay the same. Or if you heat a gas in a sealed container, its pressure will go up unless the volume can expand. You can also use it to figure out the molar mass of a gas by measuring its density under known conditions. Always make sure your units are consistent: pressure in pascals, volume in cubic meters, temperature in Kelvin, so your calculations are accurate. Keep in mind that the ideal gas law works best at moderate temperatures and low pressures, where gases behave most like ideal gases. When you understand how to use this law with moles, you gain a straightforward way to analyze many thermodynamic systems involving gases and phase changes.